Hello everyone. Good evening everyone. Good evening everyone. Am I audible to everyone? Yes? Good evening everyone. Am I audible to everyone? I'm doing great. How are you guys doing? Okay. Okay, so in the last class, we were looking at average atomic mass ka concept, isn't it? In the last class, we were looking at average atomic mass. So I defined for you what we defined, what was atomic mass. So as we said that it is impossible to measure the mass of one atom because as I said, in one particle, in one speck of dust, as I told you, in one speck of dust, there are 10 to the power 16 atoms, isn't it? So to measure mass of one atom is not possible experimentally, isn't it? So therefore what we did is, we created something called as reference. In the last class we saw, we had a reference. With the help of reference, we are going to measure the mass. So we said that in the last class that 1/12th mass of one atom of carbon-12 is equal to बोलो बेटा जी 1 AMU, which is known as atomic mass unit, and जिसका approx value is equal to 1.67 into 10 to the power minus 24 gram, which is nothing but mass of proton, also approximately equal to mass of neutron. Okay. So this we have seen in the last class. So with this reference of 1 AMU, I am going to define, let us say I want to know the mass of chlorine. So what will be the chlorine ka mass? So mass of one atom of chlorine is equal to how much? So this is 35.5 times of 1 AMU. This is 35.5 times of 1 AMU. Therefore unitless quantity, right? So atomic weight would be unitless, and if you write the mass, I will put a unit which is AMU. So we have seen this in the last class, okay? Now in this class we are going to learn about the molecule. Acha, I have one question for you guys. Let us say average atomic mass of chlorine is given to us, which is equal to 35.5, isn't it? So we always write the atomic mass of chlorine 35.5, hai ki nahi? But why it is 0.5? Why not 35? Why not 36? Again, reason being, chlorine has two stable isotopes. One is chlorine 35 and one is chlorine 37. One is chlorine 35 and one is chlorine 37. For this reason we are not having exact value. So 37 and 35, these are the mass of the isotopes. Now my question is, what is the relative abundance? Of chlorine 35 and chlorine 37? What is the relative abundance? That is my question, guys. Is my question clear to everyone? In the last class, how we calculated average atomic mass? Relative abundance into mass plus relative abundance into mass. Yes or no? That is how we have calculated. So how to find the relative abundance of chlorine 35 and chlorine 37? Basically, I want to know what is the percentage of chlorine 35 and 37 in the atmosphere, and what is given, average value is given. Can you solve this for me, guys? Can you solve this? Average mass of chlorine is given, relative abundance is given, relative abundance we have to find. Masses we have, average mass we have, how to find the relative abundance. So how to do it? Let us start like this. लेट अस से क्लोरीन 35 का अबंडेंस इज इक्वल टू x. हमने मान लिया, दिस इज माय assumption कि क्लोरीन का अबंडेंस इज x, isn't it? If you'll consider x percentage, then you'll have to divide x by 100. If you simply consider it a number, you don't have to divide by 100. So I'm not assuming percentage, I'm simply saying a number. So what is total abundance? What is the total percentage? 100%. Yes or no? What is the total number? 1. So if I assume chlorine ka value is x, abundance, so what will be chlorine 37 bolo beta ji? This will become what? 1 minus x. And average atomic mass is equal to relative abundance x into mass. What is the mass bolo beta ji? 35. Isn't it? Plus, what is the mass of this one? 1 minus x is the relative abundance. And this value is how much bolo beta ji? 37. 37. If you consider this to be percentage, you need to divide by 100. I'm not considering percentage, I don't have to divide by 100. Up to me. So from here, you solve the value of x. What is average atomic mass? Average atomic mass is given to us. What is the average atomic mass? 35.5. Now, what we are having 35x plus 37 minus 37x is equal to 35.5. From this, what do we have? We have 37 minus 2x is equal to 35.5. From here, I can say that 2x is equal to, bolo beta ji, how much? 2x is equal to 2.5. From this, we can calculate x value. X value is equal to 2.5 by, yes or no? Which is equal to 1, and this will be how much? 1.25. So, we have got the x value. We have calculated the x value. So with the help of x value, we can calculate the percentage. So that is how we are going to find the relative abundance. I hope this is clear to everyone. This is how we are going to find the relative abundance. We will calculate the value of x and we will calculate the value of 1 minus x, and that is how we are going to calculate the values. Okay. So that is how you calculate the relative abundance. So now today we are going to start with the molecular mass ka concept. Today we are going to start with the concept of molecular mass. So how to start with the molecular mass? 1.5 by, yes, sorry, 1.5 by 2. Yes, beta ji. This is 1.5 by 2. 1.5 by 2. Which is equal to how much? I think 0.75. Yes. So very easily you can observe what is x value. X value 0.75. What is x value? X is, we have assumed chlorine 35. This is x. So what is chlorine? Chlorine 35 is equal to x, which is equal to 0.75. So what is chlorine 37? Chlorine 37 is equal to 0.25. If you write in terms of percentage, what will be percentage? 75%, and this is how much below? 25%. So chlorine 35 in the atmosphere is how much? 75%, and chlorine 37 in the atmosphere is 25%. So how to calculate the relative abundance? I hope this is clear to everyone. How to calculate the average atomic mass? Ye beta ji, this is PYQ question hai, JEE mains ka question. This is JEE mains ka problem. Very simple question. Average atomic mass is equal to relative abundance multiplied by mass, whatever the mass is given in AMU, right? Plus again relative abundance of the next one multiplied by the mass. If you are writing abundance in percentage, please remember guys, if you are writing abundance in terms of percentage, divide by 100. If you are simply writing number, no need to divide. So let us say if it is given 37%, if you are writing percentage, divide by 100, or simply we can write 0.37. Is this concept clear to everyone? Give me a thumbs up guys. Relative abundance ka question all of us can do. Give me a thumbs up guys. Is this clear to everyone? Relative abundance, can we solve these kind of problems? Is it okay to everyone? Relative abundance, we can solve the problem. This is very, very important question, beta ji. Mains mein it has been asked at least 7-8 times. Very simple question they have asked. Okay. Okay. So now we are starting with the molecular mass का concept. What is molecular mass? So in the last class we have learned the atomic mass. Now we are starting with the concept of molecular mass. How to calculate the molecular mass? Very simple. Now starting with the molecule, what is molecule? So let us say we are having H2 and plus O2 forming H2O. So with the help of atoms we are forming the molecule. Right? Now what will be the molecular mass of H2? Again, if I have to measure the molecular mass of H2, how to imagine? You can't measure the mass of atom and molecule. We can't do that, but we have a reference. What is that reference? 1 AMU is our reference. So what I'm going to write is, I will write atomic weight, molecular weight of any given molecule is equal to what? What is molecular weight? 1/12th mass of one atom of carbon 12 with respect to 1 AMU. How much heavier we have? Water is how much heavier in comparison to 1 AMU. So how much heavier? Let us check. So H2O, how much bolo beta ji? 1 hydrogen multiplied by mass of hydrogen is equal to how much bolo beta ji? So 1 is the mass, 1 AMU. Let me write like this. I'll write out here. So 1 AMU multiplied by 2. 2 hydrogen, yes or no? Plus, what is the mass of oxygen? 16 AMU, which comes out to be how much, bolo beta ji? 18 AMU. That means if I replace over here 18 AMU, so this is equal to 18. That means molecular weight of water is 18 times in comparison to 1 AMU. Okay. So if I want to write the formula, so what will be the formula of molecular weight? Molecular weight is equal to molecular mass of given molecule. How many molecule? Given one molecule. So molecular mass of one molecule from given molecule divided by what? 1/12, I can simply write 1 AMU. So what will be the molecular mass then? Molecular mass is equal to molecular mass of one molecule is equal to, bolo beta ji, what is this equal to? Molecular weight into 1 AMU. We'll calculate very simple ones. Okay. For example, let us say I want to measure the molecular weight of sulfuric acid. So what is the molecular weight? Molecular weight is a unitless quantity. Please remember beta ji, molecular weight is a unitless quantity because it is a relative mass. Okay. So what is the sulfuric acid ka mass? Sulfuric acid ka mass, so 2 AMU plus sulfur. What is the sulfur ka mass? 32 AMU. Like that we will calculate. Simply add the values plus how many? Oxygen 4 multiplied by 16 AMU. So if we add this value, this comes out to be how much? 64. So this will come out to be 98 AMU. Okay. So sulfuric acid ka mass we have calculated. But if I write the molecular weight of sulfuric acid, then what is the molecular weight? Mass of one molecule. What is the mass of one molecule? 98 AMU. With respect to how much? 1 AMU is equal to 98. So with respect to this one, this will be 98. With respect to 1 AMU, 98. But what is the mass? Mass of one molecule? Mass of one molecule is equal to 98 AMU. Let us say that I want to calculate the mass of glucose, C6, H12 and O6. So this is the glucose. So I have one molecule. We have only one molecule. One molecule. How one molecule is formed? It is formed by 6 atoms of carbon, 12 atom of hydrogen and 6 atom of oxygen. That is how we have formed the one molecule. Yes. So if we have to find the molecular mass of one molecule, so again mass of carbon, which is equal to how much? 12 AMU plus 12 times mass of one hydrogen, which is 1 AMU, plus 6 times of mass of oxygen, which is how much? 16 AMU. If you do the correct calculation, the value comes out to be 180 AMU. Okay, so that is how we calculate the molecular mass. I think it is very very easy. All of you must have understood. Yes, molecular mass का concept is clear to everyone. 138 नहीं आएगा बेटा जी. Please do the right calculation. This should be 180. Is this clear to everyone? Molecular mass का concept I think very simple, right? Very very simple. Very easy, right? Okay. Yeah. So now we are going to establish the concept of mole. This is very very important. Okay. So what is the concept of mole? What is mole? Now, mole is a number. Please listen carefully. Let me explain to you first what is mole. See, we want to have, I want to quantify the particles. Okay, how many particles in a system I have, how many atom, how many molecule, or you know, how many ions, anything like that. If I want to know that, what I should do? I should calculate total number of atoms ka mass. So first for that I need to find out total number of atoms and then multiply by their mass. It becomes a very critical thought process, you know, 10 to the power 16 atom, 10 to the power 18 atom. In some systems there are 10 to the power 20 atoms. You know, so 10 to the power 20 atoms multiplying their mass, it becomes a very difficult process. So, for example, you went to the shopkeeper to know that you want to, let us say, purchase the banana. So, you don't say 6 banana, 15 banana, 10 banana. So, we have given a symbol, you know, term we have given. We have given a term. What is that term? Dozen. You go and ask the shopkeeper, give me 1 dozen of banana. So, he give you 1 dozen, which is 12, right? Now, it is very easy for the banana ka counting. 12, 14, 15. So, for that also we have simplified. I don't want to say the number 12, I want to say 1 dozen, simply. But number of atoms are so huge numbers, how to count these numbers, and then one atom ka mass is 1 AMU, then so many atoms, how to find the mass, it becomes very tedious process. So, what scientists did is, they defined a number. They defined what, bolo beta ji? Number. A big number they have defined. What is that big number? That number is called as Avogadro number. That number is called as Avogadro number. So what is 1 mole? Mole is a number. What is that number? Avogadro number. Mole is an Avogadro number which quantifies, that means it will let you know the number of particles, which quantifies the number of particles. What I mean by particles, bolo beta ji? Particles means what? Atom, molecule, or ions. Now let us say in a container, you know, there are so many atoms. So this number is huge number. What is this number? 6.022 into 10 to the power 23. Avogadro number is a very big number. So if I have in a system, let us say how much? 10 to the power 25 now, 10 to the power 25 atoms. So now for me it becomes very easy, because I can say that 10 to the power 25 atoms means what? 100 times of approximately how much? 100 times of Avogadro number of atoms are there. So I don't have to repeat these big number of atoms, right? So this Avogadro number came into the existence. So now with the help of this Avogadro number, it becomes very easy to define the mass also. What I mean by defining mass is, let us say that you are having 1 gram, let us say how much? Okay, let us say we are having 12 gram of carbon. We are having 12 gram of carbon. Now we know that 1 carbon ka atom, beta ji, 1 carbon ka atom ka mass is 1 AMU, which is how much? Which is very very small mass. Which is how much? 1.67 into 10 to the power minus 24 gram. A very very small mass. Hai ki nahi? But right now we are having 12 gram of carbon. 12 gram of carbon. 12 gram of carbon will definitely have a huge number of atoms. If 1 AMU, look into this beta ji, 1 atom contains this much, 10 to the power minus 24, just 10 to the power minus 24. But now we are having 12 gram of carbon, definitely it will contain a large number of atoms. It will contain what, bolo beta ji? Large number of atoms. So for carbon 12, how Avogadro number came into the existence, that I am telling you. Then scientists started to think, What will be that number? How to find that number? What is that number? So very simple idea came into their mind. What is that idea? That one atom ka mass is 1 AMU. Very good. One atom ka mass is how much? 10 to power minus 24 gram. And we are having how much? 12 gram. So what I can do is, if one atom ka mass is this much, ऐसा देखो, one atom ka mass is how much? 1.67 into 10 to power minus 24 gram. Or I can write 10 to power minus 24 gram contains how many atom? Bolo beta ji? One atom. It contains how many atom? One atom. So if I have 12 gram, 1.67, right? 1.67 into 10 to power minus 24 gram contains one atom. So what will be for 1 gram? Tell me beta ji. What will be for 1 gram? Very simple. For 1 gram we are having, idhar likho, 1 gram contains one atom by 1.67 into 10 to the power minus 24. Isn't it? And then what I can write? Then I can write 12 gram will contain how many atoms? So 1 by 1.67 into 10 to the power minus 24 into bolo beta ji kitna? 12. So this was the idea of the scientist. They knew that 1 AMU ka mass is this much. So how much 12 gram should contain? How many atoms? So very simple. One atom contains this much mass. 1.67, isn't it? So 1 gram contains this much, so 12 gram will contain this many atoms. So from here, the concept came. Idhar dekho beta, this number. Look at this number. 1 gram is equal to 1.67 into 10 to the power minus 24. If you divide this number, we will come to know Avogadro number. That number will come Avogadro number. So what I can say is 1 mole is nothing but Avogadro number, which is how much? 6.023 into 10 to the power 23. Right? So if I have one hydrogen atom ka mass is how much? One hydrogen atom ka mass is 1 AMU. Right? So what will be the mass of 6.023 into 10 to the power 23 atoms? If I have these many atoms, what will be the mass? Very simple. 1 AMU multiplied by how much? 6.022 or 23 into 10 to the power 23. And what is 1 AMU? We already know that. 1.67 into 10 to the power minus 24 grams into 6.022 into 10 to the power 23. If you multiply these numbers, beta ji, you'll exactly get 1 gram. If you multiply these numbers, exactly we'll get 1 gram. What means? What means is 1 hydrogen atom, 1 AMU. These many atoms are this much mass. And what is these many atoms? These atoms we are saying 1 mole. That means 1 mole of hydrogen atom, 1 mole of hydrogen atom ka mass is 1 gram. 1 mole hydrogen atom ka mass is 1 gram. So what I'm writing is, we are going to define now a term molar mass. We are going to define a term what, bolo beta ji? Molar mass. So what is molar mass? What is molar mass? Bolo beta ji, what is molar mass? How 1 gram is coming? So molar mass is nothing but, what is molar mass? Atomic weight of any given atom multiplied by gram. So that will become, let me take one more example, very simple. So let us say we are having oxygen atom, okay? So mass of one oxygen atom is equal to, mass of one oxygen atom is equal to how much, bolo? 16 AMU. And what is that, bolo beta ji? 16 into 1.67 into 10 to the power minus 24 gram. So what will be mass of Avogadro number of atoms? Avogadro oxygen atom. क्या हो जाएगा बोलो? What is Avogadro number? What is that number? 16 into Avogadro number 6.022 into 10 to the power 23, and this is 1 AMU. And just now we saw Avogadro number. इधर देखो, Avogadro number and AMU का multiplication gives us 1 gram. So this is nothing but 16 gram. So always whenever we calculate the molar mass, molar, that means mole ka mass. Mole ka mass ka unit is always gram. Please remember, listen carefully. One atom ka unit is atomic mass unit. क्योंकि atom ka mass is very, very less, which is approximately 10 to the power minus 24 gram. Isn't it? but 1 mole ka mass, 1 mole means is a big number. Mole means simply, mole means what? Number. What is the number? 10 to the power, what is the number? 6.022 into 10 to the power 23, big number. So big number ka mass also will be significant mass. And what is that mass? If you multiply by Avogadro number into AMU is equal to 1 gram. So 16 gram. Similarly, let us say if we have to find the molecular mass, that means mass of one molecule, mass of one molecule. So what will be mass of one molecule? Mass of one molecule is equal to nitrogen का mass. देखो बेटा जी ध्यान देखिएगा, one molecule. Nitrogen is AMU, not the gram, because you are talking about one tiny particle which is atom. Nitrogen, ammonia molecule. Molecule is formed by atoms. और एक atom का mass 14 AMU plus 3 into 1 which is equal to 3 AMU, which is equal to how much बोलो बेटा जी? 17 AMU. But now I'll change the question. Now my question is, find the molar mass of ammonia. Find the molar mass of ammonia. Now, simply, mole means what? Mole means Avogadro number. Mole means what? Mole means Avogadro number. So what to do? Multiply by mole. So 17 mu, very good, into, bolo beta ji, Avogadro number. And we know that mu into Avogadro number is nothing but 1 gram. So this value comes out to be 17 gram. Is this molar mass ka concept clear to everyone? Guys, is this clear to everyone? Molar mass ka concept clear to everyone? Mole means simply number. What is that number? Avogadro number. Simply remember like this. Mole means a number. What is that number? Avogadro number. Why we are using this Avogadro number? Because we want to identify small particles. Because we want to identify small particles such as atom, molecule, like that. Okay? Okay. So now we have understood the concept of molecular mass and molar mass. So very quickly we'll take one more question. Let us say we have to find the mass of, there is something called as ethanol, CH3CH2OH. This is called as ethanol, right? All of you know that this is called as ethanol. So I want you to find mass of one molecule of ethanol, mass of one molecule, and molar mass of the given compound. I want you to find the mass and molar mass. Quickly beta ji, mass and molar mass. Please find for this. CH3CH2OH. This is C2H5OH. Please find the mass of one molecule of ethanol and molar mass of the ethanol. Please find it beta ji everyone. Molar mass and mass of one molecule. Please find the values. Molar mass and mass of one molecule. Give me the values guys please. Let us see how many of you can give the values. With the unit, see this is not a number beta ji. This is not a number. This is not a number. 46 what? 46 my hair, your legs, what 46? For mass of one molecule is how much? Mass of one molecule? Very good. Srikar, right? Very good beta ji. 46 AMU and 46 gram. Very good beta ji. 46 AMU and 46 gram. 46 AMU and 46 gram. Very good. So see, yes. Very good beta ji. So this ethanol, if you find the mass of one molecule, molecule is a very, very small number, very, very small particle. For that, what we will have is C2. So carbon is 12 into 2. If you are finding for one molecule, the unit will be AMU. So 12 into 2 AMU plus what do we have? Hydrogen, 6 hydrogens. So 1 into 6, again this will be unit AMU, because we are finding for atom hydrogen. And then oxygen, what is oxygen? 16 into 1 AMU, isn't it? So we are having how much? 46 AMU. This is AMU. But if I write beta ji what? Molar mass. If I write the molar mass, what will be molar mass? Now this is 24 grams. Molar mass means mole of carbons. So two atoms 2 atom ka mass is how much? 12 mu. Sorry, 12 into 2, which is equal to 24 mu. But what is 2 mole of carbon ka mass? That is different. What is 2 mole of carbon ka mass? 24 grams. 24 grams. So 24 gram plus how much gram? 6 gram. And plus how much gram bolo beta ji? Either how many we are having? 16, right? 16 grams. So containing 46 grams. So gram is for mole and AMU is for molecule or atom. I hope this is clear to everyone. Is this concept clear to everyone? Molecular mass, molar mass. Is this clear to everyone, beta ji? Molecular mass, molar mass. Now we are going to find some formula to help us to know number of mole ka calculation. Is this clear to everyone, beta ji? Okay. Give me a thumbs up, guys. Is this clear to everyone? Is this clear to everyone, beta ji? Molar mass ka concept clear to everyone? Okay, great, guys. So now we are coming to the next topic, which is called as calculation of moles. Calculation of moles. This is very, very simple. Calculation of moles. For example, I'll start with a very easy question. Let us say that I'll ask you, okay, I'm having 8 gram of helium. What I'm having? 8 gram of helium, and I'm telling you the molar mass of helium is molar mass. Molar, not atomic mass, but molar. Molar, matlab unit will be gram. So molar mass of helium is equal to 4 gram. Now my question is, 8 gram of helium is taken in a container. Right? So what is the number of moles of helium? What is the number of moles of helium? 8 gram we have taken in a container. 8 gram we have taken in a container. What is the number of moles? Very good. Most of you are writing. What is the number of moles? Very quickly. 2, right? Very simple. 2, yes. Very easy, right? 2 moles. Because 1 mole ka mass is how much? 4 gram. 1 mole ka mass is 4 gram. Container mein how many grams are there? 8 gram. So number of moles will be 2. Number of moles will be 2. Very simple, right? So from this I can form a formula. What is the formula? Number of moles. What is the formula, bolo beta ji? Number of moles is equal to given mass. Number of moles is equal to given mass by molar mass. Given mass by molar mass. I think very simple, I think. Very, very easy. Everybody can understood. Yes or no? Now, one more formula we will have. This is formula number 1. Number of moles is equal to given mass by molar mass. Now, we know that, let us say we are having 1 helium atom. 1 helium atom and 1 mole helium, right? Mole. So for 1 mole helium, how many atoms are there? Avogadro numbers of atom, which is 6.022 into 10 to the power 23. So 1 helium mole contains how many atoms? Avogadro number. For example, जैसे मैं लिखूं बेटा जी देखो, let me take one more example. Methane. Let us say I am having methane. So what is methane ka mass? Methane ka mass is equal to 12 plus 4. If I'll ask you molar mass, 16 grams. 16 grams. If I'll ask one molecule ka mass, 16 AMU. 16 AMU. Now we know that 1 mole contains how many number? Avogadro number. So I am framing the question for methane. Let us say that I have given you in a container, I have given you methane ka particle. So methane ka number I have given you, let us say I have given you 10 to the power 22 atoms. How many atoms I have given you, Bulbata ji? 10 to the power 22 atoms I have given. Now my question is, find out the number of moles of methane in the container. Find out the number of moles of methane in the container. Rather than atom, this is molecule, okay? 10 to the power 22 molecules, right? So we are having 10 to the power 22 molecules. Question is, find out the number of moles. We know that 1 mole of methane contains how many molecules, Bulbata ji? Avogadro number of molecules. So what is the formula number of moles? Given particle 10 to the power 22 by Avogadro number. This will be number of moles. So I can frame the formula. Number of moles is equal to, because one particle contains Avogadro number, so if you are having more than Avogadro number, so given number divided by Avogadro number. If you are having more than Avogadro number, mole will be more than 1. If you are having less than Avogadro number, moles will be less. So we are having two formula. Formula number 1, number of moles is equal to given mass by molar mass. Formula number 2, given number. What is that number? Number of fundamental particles, which is what? Atom, molecule, ions, like that. So let us say, if I'll ask you, in 1 mole of methane, what is number of carbon atom? In 1 mole of methane, what is number of carbon atom? So in 1 mole of methane, what is number of carbon atom? Can you tell me? What is number of carbon atom in 1 mole of methane? Can we quickly get the answer? In 1 mole of methane, what is number of carbon atoms, beta ji? In 1 mole of 1 mole of methane, how many number of carbon atoms? No. Number of carbon atoms. Number of carbon atoms in 1 mole. Very good, beta ji. 12 Na? No. 1, 12, no. Avogadro number. Very good, Srikhar. Avogadro number. Very good. Idhar dekho. Let me frame the question like this. 1 molecule methane. You guys are not getting it. 1 molecule methane. 1 molecule methane, because molecule is formed by atom. So how many atom? 1 carbon atom. And how many hydrogen atom? 4 hydrogen atoms. Because molecule is formed by atoms. But now I am not asking about the molecule. I have asked about the mole of methane. Mole of methane means, what I told, mole means, simply remember, mole means Avogadro number. What is mole? Avogadro number. So in methane, number of carbon ka mole. What is the carbon ka mole? Carbon ka mole is equal to 1. So what is the number? Number kitna ho jayega? 1 mole means Avogadro number. So 1 into Na. If I'll ask you, what is the mole of hydrogen atom? What is the mole of hydrogen atom? Mole of hydrogen atom. So mole kitna hai bolo beta ji? Hydrogen ka mole kitna hai? 4. But if I'll ask you number of hydrogen atom, this will be 4 Na. I'll solve one more question so that everybody could be clear about that. One more question so that everybody gets the idea. I'm taking a big molecule. Let us say we are having glucose, C6H12O6. Let us say we are having 1 mole of glucose. 1 mole of glucose we are having. Now in 1 mole of glucose, I will frame 2 kinds of question. Listen carefully, beta ji. 2 kinds of question. Question number 1, type 1. What is the type 1? What is the number of moles? What is the number of moles of carbon, hydrogen and oxygen? Question number 2. What is the number of carbon, hydrogen, oxygen atoms? 2 questions. 1 mole of C6H12O6 we are taken in the container. Question is, what is the number of moles of carbon, hydrogen, oxygen? Give me this answer first. And then number of carbon, hydrogen, oxygen atoms. Moles. Give me the answer. First question का answer बोलो बेटा जी. Carbon, hydrogen, oxygen in terms of moles. 6, 12, 6. Very good. Number of mole of carbon. 1 mole contains 6 mole of carbon. Very good. Then 6 Na, 12 Na, 6 Na. Very, very good beta ji. So mole, 1 mole contains 6 mole of carbon. 1 mole contains 12 moles of hydrogen. 1 mole contains 6 moles of oxygen. But now we are coming to the atom. 1 mole contains how many atoms? 1 mole contains how many atoms? Avogadro number of atoms. So 6 mole will contain 6 Na. Very, very good beta ji. Hydrogen will contain 12 Na Avogadro number, and oxygen will contain 6 Avogadro number. Very, very good beta ji. I hope this is clear to everyone. Yes? Avogadro number ka concept. So we have 2 formula. Formula number 1, number of mole is equal to given mass by molar mass. Formula number 2, given number of particles by Avogadro number. So we are having two formula for number of moles. We are having the third formula for number of moles. Acha, okay, let me ask one more question. Total charge on 1 mole of aluminium 3+. What is the total charge on 1 mole of aluminium 3+? Can you give me the answer for this? What is the total charge on 1 mole of aluminium 3+? Total charge on 1 mole of aluminium 3+. 1 mole, 3 Na is not the charge. Unit should be there, beta ji, coulomb. I'm asking the charge, coulomb charge. I'm not asking +3 -3. I'm asking how much coulomb. Coulomb I'm asking. Charge ka unit I'm asking. How much charge? I'm not asking some number. You should have the unit, coulomb unit. What is the charge? Coulomb unit, I'm asking about that. 3 Na, no. 3 Na kaise hoga? +3 Na, -3 Na. What is that charge? 3 coulomb. Somebody is saying 3 Na. 3 Na. 3 Na is not the charge. Okay, let me frame like this. What is the charge? What is the charge on 1 proton? Tell me this, beta ji. All of you tell me this. What is the charge on 1 proton? Tell me this. Charge on 1 proton in terms of coulomb. Tell me this value. What is the charge on 1 proton? 1.6 into 10 power -19. -19. So charge on 1 proton is equal to 1.6 into 10 power -19 coulomb. This is 1 proton, single proton. In 1 atom, there is a 1 proton. Uska charge is 1.6 into 10 power -19 coulomb. Now, what will be charge on 3 protons? 3 protons. So 3 into 1.6 into 10 power -19 coulomb. Isn't it? Now, how many protons we are having? Excess. Excess number of protons are 3. I hope this is clear to everyone, right? Aluminium contains 13 electron and 13 proton. 3 electrons are removed. 3 electrons are removed. So we are having 13 proton and 10 electron. 10 electron and 10 proton cancel each other. What do we get? Extra 3 proton. We get extra 3 proton. 3 proton. Okay. So now 3 proton ka charge is this much. But are we having 3 proton? No. We are not having 3 proton. We are having 3 moles of proton. We are not having 3 proton, beta ji. Mole. This is 1 ion. This 1 aluminium 3+ is ion. 1 ion. 1 ion ka charge is this much, beta ji. 1 aluminium 3+ ion ka charge is this much. But we are not having 1 aluminium 3+. We are having 1 mole of aluminium 3+. 1 mole of aluminium 3+. है कि नहीं? So what is the total charge? 1 इसके लिए इतना हो गया. So 1 mole के लिए, for 1 mole, 1 aluminium 3+ का charge is equal to 4.8 into 10 power -19 coulomb. So 1 mole aluminium 3+. Wow. 1 mole is equal to 4.8 into 10 power -19 into, bolo, Avogadro number. And let me tell you, 1 charge on electron, right? 1 mole Avogadro number 6.023 into 10 power 23. And what is the charge on electron? 1.6 into 10 power -19 coulomb. If you multiply these numbers, 1 mole charge on electron. So this is, what is 1 mole? Avogadro number. And what is the charge? 1.6 into 10 power -19 coulomb. So if you multiply these numbers, this approx value I'm saying, this comes out to be 96,500 coulomb per mole. And this is called as Faradays. Have you heard this? Faradays? 1 Faraday. So what is 1 Faraday? 1 Faraday is equal to, yes, 3 times 96,500. Very good, Samba. So this is total charge on 1 mole of electron. 1 mole of electron is total charge is how much? 1 Faradays. 96,500. This is how it will come. So because we are having 4.8, this means this is 3 into 1.6. So this is 3 into how much Faradays? 1, right? So this will be 3 Faradays. This will be 3 Faradays. Is this clear to everyone? This charge का concept, is this clear to everyone? Give me a thumbs up, guys. Is this charge का concept clear to everyone? Charge related with mole, is it clear to everyone? This charge का concept is clear to everyone? Yes? Charge का concept clear to everyone, right? Okay. Great, guys. Now we are coming to the concept of still having some doubt. What is your doubt, Josika? Josika, can you let me know your doubt? What is your doubt? Very simple. If I'll have to know the charge on Na plus 1 ion, 1 Na plus ion ka charge is 1 proton ka charge is equal to 1.6 into 10 power minus 19 coulomb. Very simple. If I have to know 1 mole Na plus, 1 mole Na plus, mole का मतलब Avogadro number, mole का Avogadro number, तो Avogadro number into charge 1.6 into 10 power minus 19 coulomb. If you multiply these numbers, approximately it will come 96,500 coulomb per mole. Because this is 1 proton, and this is what I am saying, कि 1 proton or 1 electron, sign will change. For 1 electron negative will come, for 1 proton positive will come. So what is the value? For 1 proton or 1 electron, what is the value? 96,500 coulomb per mole. Okay, so this was about the charge and this. Now we have understood the concept of basic idea about the mole. We have understood the basic idea about mole. Now there is a very, very important formula. Just wait few minutes, guys. So third formula to find the number of moles is via ideal gas equation, which is equal to PV is equal to nRT. This equation we'll study in a chapter known as gas state. There we'll study this equation. Because we have learned the unit interconversion very well, so I want to understand the formula, third formula, number of moles. 2 moles beta ji multiply by 2. So that will become 2 Faradays. For 1 electron, 1 Faraday. 2 electron, 2 Faraday. 2 mole electron. 3 mole electron, 3 Faraday. 4 mole electron, 4 Faradays, like that. So PV is equal to nRT. So what is number of moles ka formula? Number of moles ka formula is equal to PV by RT. So this is the fourth formula we are having. Number of moles is equal to PV by RT. This is the fourth formula we are having. So third formula. So what should be the units? Pressure, volume, R and T. Keep the SI units. We should have SI units. Okay. Number of moles. Now there is a term called as STP, which is known as standard temperature and pressure. Called as standard temperature and pressure. What is standard temperature and pressure? In this condition, pressure is taken as 1 atm. In some books, you will find 1 bar. But because we know that 1 atm is equal to how much? 1 atm is equal to how much? 1.01325 bar. So there is not a huge difference. Very minute difference we are going to get. Very, very minute difference. So it doesn't matter much. So I'm having this STP condition, which is known as standard temperature and pressure. That means standard pressure of the atmosphere, which is 1 atm. And temperature we will take 0 degrees Celsius, which is equal to how much? Bolo beta ji, 0 degrees Celsius, 273.15 kelvins. Okay. So I have to find the number of moles in terms of volume. I have to find the number of moles in terms of volume. This is only applied for ideal gas. So what will be number of moles? Pressure. What is pressure? 1 atm into volume. I don't know. Volume of the gas I don't know. What is the R value? R value is equal to here 0.0821 liter atm Kelvin inverse mole inverse. And what is temperature? 273.15. If you adjust these values, this will come out to be, number of moles comes out to be volume by 22.4 liters. This value comes out to be N is equal to V by 22.4 liters. If you substitute these values, you calculate it, this value will be like this. Now the thing is, sir, from where we are getting this R value? You have written this R value, from where we got this R value. So to understand this R value, let us come to know something which is called as density. Okay. So density, we are going to start tomorrow actually. It will take some amount of time. So tomorrow I'll come with some problems of calculation of number of moles, and we'll go through some density ka concept, which is very, very important. Okay. And density, there are two kinds of density actually. One is called as absolute density and one is called as relative density. So we are going to use this concept of absolute and relative throughout the chemistry. So tomorrow we'll start with that. Okay. I'll upload few problems also tomorrow for the calculation of number of moles and this and that. Okay. So thank you guys. Thank you so much to be present in the classroom. Tomorrow we'll start with the concept of density and we'll solve some problems from the mole concept. And then there is a concept known as percentage composition, which is very, very important. So we'll start with that. Okay. Thank you so much guys. Thank you. Okay. Tomorrow, I mean Monday. Yeah. Okay. Thank you guys. Thank you everyone. Take care. See you on Monday guys. See you on Monday. Thank you.